Hello, my friends. Today we're going to talk about the interlock. So this session today talking about something related to safety for people and safety for machine at same time. So if we like, for example, if we have like here in this picture, we can see here the robot working inside with the piece of manufacturing and the operator working outside, and there is a guard around the working area, and there is a lock. You can see the red lock to prevent the operator to enter inside when the robot working, for saving the operator. Okay, so this is the safety of people is very important and very crucial for the whole of the industries production, especially in the country that has a restriction of the security for people and worker. So here we are talking today about the interlock. So what kind of interlock we have? So interlock, as you can see in this chart, you can see in the left the safety interlock, and this is related to human, as I showed you in this picture, safety for operator, workers, and everything. And on the right, you can go with the equipment interlock. So for equipment interlock, we have been doing this interlock for equipment based on one of three types of interlock. So we have a mechanical interlock, we have electrical interlock, and we have at the end the logical interlock, which is our interest here and our scope. And also it is the most important one and the most common in all industries to have a logical interlock. You know why, my friends? Because logical interlock is very easy to implement, very easy to change, very easy to doing with flexibility to changing the logic with the scenarios, different scenarios based on the operation scenarios. And the other thing, it is easier than having electrical or mechanical interlock. So we will try to go through this thing today for the logical interlock. But first, let's have a little bit talking about the mechanical interlock and the electrical interlock, because it is like giving you the idea about the interlock. So for mechanical interlock, so you can see here, this is one kind of mechanical interlock exists in your car. So here you can notice when you putting your key and when you take it out from its place, so you can find the steering gear is locked. So that's happening by mechanical interlock, and this mechanical interlock depends on the position of the key. If it is like in right position and the inside its place, so you can unlock the gear, otherwise the gear will be locked mechanically. So the other type is the electrical interlock, but this is another. It seems like electrical, but this is another example of the mechanical interlock. You can see here the two contactors to connect the motor in two ways. The first one on the left and the second one on the most right, and you can see here this point on the left here. So this point showing a mechanical interlock, which by having this point, it guarantees there is no way to having both of those contactors connected at the same time. So you can see what the consequences might happen when we have both of them without the mechanical interlock. So you can see on the right, if you have doing something like this, you will have 100% a short circuit. A short circuit between the power lines, and the motor will be damaged for sure, and you might go into further complication based on this scenario. So moving forward to the electrical interlock, so you can see here the electrical interlock. You can having two circuits, one circuit on the left, circuit 1, circuit 2, and these are like connecting electrically like when one is requested, so the other one should be in the opposite logic. So if one is on, the other one will be off, and if one is off, the other one will be on, to energize the load, which is a lamp here. So here's the lamp. You can see the lamp has only one way with the electrical interlock, otherwise it will not be energized. On the other hand, you can see in every circuit for the motor or pump or whatever equipment you have, you will have like a thermal overload. This thermal overload is a kind of electrical interlock. If the temperature is okay, you can see in this part if the temperature is okay, so this normally closed, the contact will be normally closed, and the connection will continue to energize the motor when this contactor is turned on. But if the temperature at any time goes further than the desired temperature, so this contactor will turn it on, and once it is turned on, so this thing, like you can see, this connection will be open, and the motor will never energized, even if you applied the power through this contactor. Moving forward to the logic interlock, which is our scope. So here you can see we have like two pumps, and we make like interlock for those pump. Like we made a condition for pump 2 for having pump 2 running. You can see in the second rung here. So you can see there is one condition for pump 2 to run, to have pump 1 is running. You can't run anyway pump 2 without having the pump 1 is running. Okay. Then here, moving to the ladder logic, which our course and tutorial here. So yeah, you can see this is one example to like make an interlock based on time. So you have timer here. If you still not aware with timer, please back to our recording for the timer. We give an example for this type of on delay timer. So you can read the logic now because you're expert, my friends. So you can see here, if you start button requesting to run the output or this contactor. So this contactor will now have only one condition, which is the timer is on, the timer done is on, and that happened only when the timer counts and by start, and the start counts and reaching to 3 seconds. After 3 seconds, its done bit will be energized, and this done bit will activate the contactor, as you can see. Oh, that's very good. You are here up till this point, and here's where our example, which is there in every or in most of the your life for working with many actuator or many outputs, which are depending on each other in operation. So you can see simply here you have to bump, and the bump 2 can't run if bump 1 is not working, and same thing, bump 1 will not be able to run until bump 2 is not working. So at least you have the maximum. You have only one bump running at a time. You can't ever run the both of them in same time, and this is a requirement coming by your client or your customer, asking you, hey, I need to run these two bumps, but one will be like a backup of the other, so you can't run both of them in same time. I want to run bump A or bump B, one of them at a time. So you here just putting a condition for bump 1, which is connected to bump 2. So if bump 2 at any time is running, so this contact will turn it from normally closed to normally open, which is isolating this path for the contactor of the or coil of the bump 1 from the power line. And same thing here for bump 2, you have one condition, like bump 1 is not working, but if it is working, that means this contact will be on, So this bus will be disconnected and the bump 2 can't work as the time bump 1 is working. So let's practice this thing as usual with our simulator to see how this is working. So this is one last one. I'm starting every time from same from the last program we've made in the last session for saving the time, because you know when requesting this TIA portal to starting from beginning and creating a new project, that takes a long time, and I need every single moment in the video with the benefit comes to you with the benefit for you. So here what we will do here, so we have two motor, we have to run one motor like this. So this is the start, your start button. Okay, let's naming lately, and you have one for guarantee the pump is not working, because you're switching it only when it is stopped, and another one for interlock from the other pump, and this is the pump itself, and we need to make latching, which now you should know the latching, what it does it mean. And if no, you can back to the lecture and you see what's about it. Same thing here for the other pump. So we need the start, we need to make sure it's not running and the other one is not running, and this is the coil for the pump itself, and now this is the latching for this pump. Okay, so here for sure motor 1. I don't know if we have it or not, so let's use this one as a motor 1. Okay, and we'll name it motor 1 or pump 1 like the example. So this is B1. Okay, and this one is oh, we have another Q or what? So we have another Q here, like another output, I mean. We'll see. So let's see. So let's say we have like M101, for example, and this one I will call it like B2. Okay, so this is two pumps, so I need this one for pump 1. I need to make sure it is not running, and the same thing I need like also B2 is not running. And here this is the start button, so I can requesting here starting for this one. So I will say like this, and this one will be for sure B1. Okay, to make the latching, and this one will be like M3 for starting the other pump. So let's name this one like naming this one like B1 start. Okay, and this one I'll name it like B2 start. Yes, and this one for sure will be B2. Make sure it's not running already, how it is running, and I'm requesting it to running. Yeah, okay, and same thing, B1 shouldn't be running at that moment. I think this thing is yeah, I think that's good now. So B2 also. So now here we go. We are good to go now. So we're just starting our simulator as I teached you before. And you can see once the simulator is started, the downloading the program initiated. Loading. Finish, and just running our program and take our simulation and see if we are good or bad for our programming. I mean, if for sure we are good, but we need to make sure it's working. So here, because I started this one, so now this one is working. Okay, so let's try to start while the other one is running. Let's start to running this one and see what happened once I requested one of them, the other one can't working, because now I just opened this bus from B1. And same thing here, if I started the other pump, what's going on? Yes, for sure, this one, like if I started this one to open, it can't open. Why? Because this one is already open. Okay, this one is already open. So if it tells me like B1 is running, so you can't run both of them. So if you have a stop button here, it will be okay. Otherwise, you can just hear like turning on this one. So if you're turning on this one, I think we should, because it is already on. It is already on. So now, if you have such this thing, you can, like, if you switch this one to on like this, okay. So you need, I think you need a stop button for make this thing running, because already you have now, like you have now latching, like this one need to be on. So this thing is the start button, and this is not working, which is this, and this is working, and this, I don't know, this B1 should be okay. So if this one is like on now, okay, so let's correct this thing with having the stop button. So we have another push button here, which will be like a stop, and another one here to stop. So this one is a stop button for the first one, and this one stop button for the other one, pump 2. So now let's try another time and see difference. So here I'm running, okay, simulating, and see both of running now. So now you can see this one is started. So if I like requesting a stop for this one, let me starting this one to see. So this one already when starting, and they make the B2 is open. So once I requested this one is not requesting. But if I requesting this one again, okay, so I requested it, but it tells me like, oh, B1 is running. So I need to stop just this one. And once I stop this one, what happened is, like, I just stop this. Oh, I need to like make this one like this is a stop button. So I stop this bump. The other bump is running. Okay. Same thing if here if I stop this bump. Okay. So I need to just to restart again this one. Yeah. So I started this one, and I need to just for now, I make this one force it to true, so I need to force it to end. As you can see here, it is very clear, the interlock here preventing the two bumps to work together. Thank you for watching, my friends, and I hope to meet you very soon in the next session. And feel free to pause the video at any time and try yourself to understand and practice everything. Thank you, and have a good day. Bye bye.